All right, ladies and gentlemen, here are the solutions to the solving one-step, one-variable equations for Algebra 1, starting with number 1. N minus 5 equals negative 4. Okay? First thing is to just draw a quick little vertical line and then do the additive inverse here. So plus 5. Now to keep the equation in balance, come over here, plus 5. We cancel this out because it sums to 0. And now n equals negative 4 plus 5. Most common wrong answer was negative 9. That's not true. Negative 4 plus 5, okay? Negative 4, negative 3, negative 2, negative 1, 0, 1, okay? So it's 1. N equals 1. Number 2, n plus 10 equals 16. Let's write it down. Oh, I guess I better circle A. Okay, so number 2, n plus 10 equals 16. Well, first step is always the same. Vertical line. Now we apply the additive inverse. Positive 10 becomes negative 10 here. So we minus 10 on both sides is what most students say. Well, 10 minus 10 is 0, so I cross it out over here, bring down that n, and now 16 minus 10 is 6. Students in the class who are finished need to be doing corrections on any that they got wrong. If you're not finished keying your answers in, please finish keying those in. You have 4 minutes before it auto closes on you. But then be doing this. Okay, so be correcting your test, because I'm going to give you back half credit for correcting your test. Right, those folks who already did corrections, just please continue working silently. All right, moving on to number 3. Oh, sorry. On number 2, I need to put this in a box and choose A. Number 3, 7 plus A equals negative 1. So I add some number to 7, and it equals negative 1. So I'm already thinking it's got to be negative 8. Okay, but we'll prove it with algebra here, because I'm increasing some number by 7. So I'm moving to the right 7 places on the number line from the original number, and I end up at negative 1 when I'm done moving. So I had to start at negative 8. So just by common sense. But if we're going to use algebra, we're going to do the additive inverse. Now, this often confuses students. That's a positive 7, so we would do a minus 7 on both sides. And now on the left, we cancel. On the right, well, we have A equals. And now on the right, we essentially add 1 and 7 to be 8, but the answer is negative, so it's negative 8. So A equals negative 8. Which would be A on this test form. Moving on to number 4. A minus 1 equals negative 1. So it's pretty easy to do in your head. You take 1 away from something, and you're at negative 1. Well, that thing had to be 0, right? So it's got to be B. But let's prove it using algebra. A minus 1 equals negative 1. So, there's the thinking part where you want to use common sense like we just used. And then there's the algebra part that actually tends to trip people up quite a bit. But always make sure that the common sense part is making sense with the algebra part. So we're going to reverse this operation here using the additive inverse. Negative 1 becomes positive 1. We do the same on both sides to maintain that balance. Some people draw lines like this. That's fine. You just have to know that that's 0, so it basically goes away. Now A equals negative 1 plus 1. So many people put negative 2 that I started to question my own sanity. Negative 1 plus 1 is 0. Okay. So it's B for B. Moving on, ladies and gentlemen, brothers and sisters, comrades and friends, fellow countrymen and women, workers of the world, students, learners, scholars, budding mathematicians, future college graduates. Let's do number 5. N minus 6 equals negative 16. You can do this in your head. You take 6 away from some number, and you're at negative 16 on the number line. So that thing had to be negative 10. It just had to be. But we'll do the algebra to prove it, ladies and gentlemen. So additive inverse says plus 6 plus 6. Okay? Some people draw the lines. They say to each his own, okay? Everybody's got their own little quirky, special way of doing everything. That's what makes us interesting people. Now, negative 16 plus 6, well, that's negative 10. Okay? So, D. Number 6, ladies and gentlemen, we're moving on to, multiplication, division. I think these are easier. X over 6 equals 4 over 3. Now, the one little special secret that will prevent you from getting these right is if you forget that there's a 1 right there. Okay? So we have to flip it, right? Flip it. Well, 1 over 6. So flip that. Ladies and gentlemen, it's just 6 over 1. 6 over 1 on the left. Now, you did this on the left. Remember, okay, we got to do it on both sides. So it's going to be times 6 over 1 on both sides. Now, why do we do this? For a very special reason. Okay? We want to cancel those 6s, and we don't care about the 1s, okay? You can put cancel on the 1s, but it doesn't matter. It just means that 6 divided by 6 is 1. So that basically isolates the x variable. That's what we wanted. We wanted to get x by itself. Now, you could do 4 times 6 is 24, okay? 3 times 1 is 3. We say multiply across the top, across the bottom. 24 divided by 3 is 8. Okay, so the answer is 8. I like doing it this way. Instead of writing 24 over 3, I like prime factoring everything. So instead of 4, I write 2 times 2. Instead of 6, I write 2 times 3. And then I write all of that over 3. Okay. And I see I can cancel the 3. And so all that's left is 2 times 2 times 2, which is 8. This way of doing it is more complicated when the problems are real simple like this. But when they get complex, we'll see one later that's a little bit harder. Then I think the prime factor method is way easier. Later on, you'd end up having to multiply 12 times 15 in one problem. There's no need for that. Number 7, we have m over 7 equals negative 7. Now, just think about this for a second. You take a tree. Okay? No. You take something and you cut it into 7 pieces. Each piece is negative 7 inches long. And I know that doesn't make a ton of sense. It doesn't make a ton of sense to think about chopping something into negative segments. But think about it for a second. You take some number, you chop it into 7 pieces, and it's negative 7 units each piece. It has to be negative 49. Okay, you cut it into 7 pieces, you're going to have negative 7 things. This really confused the ancient mathematicians for a long time. They thought negative numbers didn't exist, but we know better. So let's show the algebra. M over 7 equals negative 7. Okay, now I'm kind of cheating here because I'm writing it in a way. The first thing I want you to do is to put this negative 7 over 1. And that's going to save you in most cases. Okay? Now, the other thing we need to do is put a 1 in front of the m. Now we flip it, ladies and gentlemen. So instead of 1 over 7m, we'll do 7 times 7 over 1, like this. And you're multiplying. And so it's like 7m. I never show this step. I'll show it. 7m over 7. Okay, that's what that multiplies to. And then you cancel those 7s, leaving the m behind. Well, now, negative 7 divided by 1, we have to multiply this side, because we'd be out of balance, by 7 over 1. Okay? Well, just multiply across the top and across the bottom. Negative 7 times 7 is negative 49. That's just a math fact. You don't have to write it over 1, okay? You could write negative 49 over 1, but that's superfluous. It's just negative 49, which is what we thought before we even started doing the showing the work. A lot of people say, well, if I can do it in my head, how come I have to show the work? That's because right now you can do it in your head, but there are problems not too far down the road that you definitely cannot do in your head. If you can do them in your head, I will give you my salary and I will sit in the desk and let you be the teacher. Number 8, negative 10r equals 20. I assure you none of you would want my salary. Okay. Now everybody says the same thing. Divide both sides by negative 10, right? That's exactly what we're going to do. Divide both sides by negative 10. Well, that cancels here and here. And we have r equals, well, 20 divided by negative 10. You can cancel the zeros. That doesn't really mean anything, but it makes it easier It's 2 over negative 1, which is negative 2. Okay? Negative 2. Most people got that one right. Okay. Moving right along. Moving right along, ladies and gentlemen. On to number 9. N over 8 equals negative 5 over 4. Let's go ahead and write it down. N over 8 equals negative 5 over 4. A lot of people ask me, well, does the negative go with the 5 or does the negative go with the 4? And here's the answer. It always goes with the top number, okay? Always goes with the top number, ladies and gentlemen. Okay, now remember, there's a 1 in front of that n. Draw your line. Now, remember, just flip it. Do what Giselle said. Just flip it. So instead of multiplying n by 1 over 8, well, I'm going to multiply by 8 over 1 now. Undoing the operation with this reciprocal multiplication. We'll do the same thing over here. 8 over 1. Now that allows us to cancel everything, leaving behind n equals. And now it's time to play a little game called Can You Multiply Across the Top and across the bottom. Negative 5 times 8 is negative 40. Negative 40 over 4. Okay, so negative 40 over 4, ladies and gentlemen. You divide negative 40 into 4 pieces. Each piece is negative 10. Okay, negative 10. That is the answer. Okay, the respuesta. Negative 10. Okay, number 10. 5m equals negative 10. And 5m equals negative 10. Well, step 1 is always the same. Draw that vertical line. Now everybody's thinking the same thing. We want to reverse that multiplication operation. So we're going to divide both sides by 5. Cancel, cancel. M equals negative 10 divided by 5 is negative 2. Boom. Put that in a box. And move on to the next problem. Number 11. M minus 5.5 equals negative 2.1. Now here we are beginning to enter into that stage where you can't do it in your head because you start making silly little mistakes. So we'll just write it out and we'll let the algebra help us. See, our brain is kind of built for integers, whole numbers, things like that. We don't do so well with decimals and mixed fractions and all that stuff. So it's best to let the math tell you what to do. Okay, well, first things first, I'm going to draw my red line. Just like that. And then reverse engineer this guy. This is negative 5.5, so I'm going to plus 5.5 on both sides. And here we're going to run into a little bear trap. Okay? You ever seen a bear trap before? Not something you want to run into. Now we have m by itself on the left side. Now, if you would just attempt to, I don't know what you would attempt to do here. I saw people writing negative 7.6. I would say that was the most common answer. Wrong. Okay, wrong. What you have to do on paper is you have to flip these two and perform subtraction. Now people say, well, how do you know? How do you know that? How did you know to do that? Well, here's the way you look at it. The bigger number has to go on top. When the signs are different, you're going to perform subtraction. Okay, the bigger number has to go on top. Well, now just subtract like normal from third grade. 5 minus 1 is 4. 5 minus 2 is 3. But, and here's the thing, it's negative 3.4, okay? No, it's not negative 3.4. It's positive 3.4. Here I'm making the same mistake that I was telling you guys not to make. It's not negative. The way that you determine that is you look at these two numbers and you say, which one is bigger, the positive number or the negative number? Well, the positive number is bigger, so the result of the subtraction by law has to be positive. Okay? So it's going to be positive 3.4. Okay. Moving on to number 12, ladies and gentlemen. Number 12. X plus 2.8 equals 0.7. So I write X plus 2.8 equals 0.7. Okay, now that leading zero right there is not a significant figure. But if the 0 had come after the 7, it would be a significant figure. Okay, now we're just going to minus 2.8 on both sides. But again, you see we can't do this in the normal way, right? You can't just proceed like that. You can't do that. You got to switch the positions of these two. Now, in this case, the bigger number by magnitude is, if you just don't look at the sign, you just look at the numbers, the bigger number is the negative number. So the answer is going to be a negative number. So look, you can already go through and eliminate all these other answer choices. That's like a trick for a test. But here's how you do it on paper. You're going to do 2.8 minus 0.7. Okay? Like I said, we don't need that 0. Well, 2.8 minus 8 minus 7 is 1. Put a point, and then the 2 comes down, but it's negative. Okay? So now X equals negative 2.1. And that's it right there. Moving on to number 13. We're almost done, ladies and gentlemen. I know some of you prefer watching this to doing anything else because it's so exciting. But it is, all good things have to come to an end. So we're almost done. 2.24 plus n equals, a lot of people miss this one, equals negative 1.76. Most common problem I saw here is people just being careless and forgetting the negative sign. All right, now remember, this 2.24 is a positive number. So if you're going to do the inverse operation, you have to do minus 2.24. And remember, we have to do that on both sides, minus 2.24. So here's the thing. You're standing at negative 1.76 on the number line. You're going to be taking away 2.24, which means you're going to get more negative. So you're basically adding these two numbers, and that's how we think about it. When both of them are negatives, you add. Okay, so 6 plus 4 is 10. Carry the 1. 7 plus 2 is 9. Plus 1 is 10. So put a 0, put a dot, carry the 1. And now 1 plus 1 plus 2. Well, that's 4. But it's negative. So it's negative 4.00, or n equals negative 4. Okay. Lots of silly mistakes there. It's not. Number 14. 14.
Bruh.
R minus 7.91 equals negative 17.51. Okay, well, it looks like it's hard, but we just start with our red line. We don't let anything phase us. And now we're going to add 7.91 to both sides. Okay. Draw that line. Draw that line there. Now cancel out, and you're right, R equals. Well, we're in the same boat here. We have negative 17.51 plus 7.91. Well, the negative number has a bigger absolute magnitude, so the answer will still be negative. Unfortunately, all of those answers are negative. But here's one answer you can get rid of. All right. You're only taking away 7.9 from 17. So it can't be negative 2. All right. All right. So now let's do this. We're doing this as a subtraction problem. 1 minus 1, 0. 5 minus 9. I can't do that. I got to borrow. I go to the 7, but I can't stop there because this 7, if I take one away, it'll be 6 and then it won't work. So I got to go over here. I got to borrow twice over, make this a 0. Now, you don't make this a 17, you make this a 16. Okay? And then you make this a 15. So you add 9 to the 7 and you add 10 to the 5. Now, 15 minus 9 is 6. 16 minus 7 is 9. So, final answer, negative 9.6, ladies and gentlemen. Negative 9.6, ladies and gentlemen. Just realized I didn't put any of these in boxes. Putting them in boxes helps the teacher a lot. Okay? It tells my eyes where to go on the page. So I'll try to model that behavior. Number 15. Exciting times.
Wow.
Only 5 more to go.
Bruh.
N plus 9.6 equals 13.6. Well, without even thinking, I'm going to draw a vertical line. I think some of you are starting to see how much I'm using this protractor as I do math. That's why I gave you one, okay? So that you would be able to do this. I'm going to do reverse the operation of addition. So it's minus 9.6 on both sides. Minus 9.6 over here. Luckily, this time I'll just be able to do straight subtraction. I've got n equals, okay? And now I'm doing 13.6 minus 9.6. 6 minus 6 is 0. Well, I can't take 9 from 3, so I got to borrow. Take this, make this a 0. Now add 10 to 3 for 13. 13 minus 9 is 4. Is it negative or positive? Well, the smaller number was the negative number, so the result has to be positive. Put this in a box, and let's go. I just now looked up here to see that 4 was an answer choice. Moving on to number 16. Damas y caballeros. 4 over 3b. People had trouble with this. Equals 4 over 9. Well, we have to remember the R word. Multiply both sides by the reciprocal. Okay? So I'm going to multiply both sides. See how I'm building this up? You know, everything's going to be the same. Well, the reciprocal of what? Reciprocal of the thing to the left of the letter, right? So over here, 4 over 3, reciprocal is 3 over 4. Just go fill this in on both sides like you're filling out a duplicate entry. Let's see what happens. The 3's cancel here. Look at this. The 4's cancel here. Amazing. Now look over here. These 4's cancel like this. So that's lovely. Well, now we have B equals 3 over 9. Well, ladies and gentlemen, we can reduce this fraction by dividing the top and the bottom by 3. Some people are still struggling with this concept, so I'll write it out. Like what we're doing is we're dividing the top and the bottom by the greatest common factor of the numerator and denominator. The greatest common factor of 3 and 9 is 3. So we divide both top and bottom by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So B equals 1/3. Now this was confusing because the letter B in the problem equals 1/3, but the answer on the paper is C. It's kind of, wish they wouldn't use A, B, C, and D as variable letters, but I'm not in charge of the company that made this worksheet. And that's how it goes, you know. Now number 17, final 4. Right? We got 4n over 15 equals negative 12 over 5. What goes with the top? The negative goes with the top. Negative 12 over 5. Okay, this is that problem I was telling people about where it's either super hard or super easy. So first we're going to draw our line, and I put 2 multiplication dots. Let me set these fractions up. Okay. Now just flip it. So 4 over 15, flip it. 15 over 4. 15 over 4. Now it's very important. This is important. These all cancel, by the way, leaving n by itself. Now, if you sit here and try to multiply negative 12 times 15 over 5 times 4, you're wasting mental effort. Instead, what you need to do is take negative 12, break it down. Look in the denominator. There's a 4 down there. I know that one of the factors of negative 12 is 4. So I could do negative 3 times positive 4 and get negative 12. So I'm going to replace this negative 12 with negative 3 times 4, like this. Okay? And 15. My prime factorization of 15 is 3 times 5. I didn't choose to prime factor the 12 on purpose. Now let's rewrite this as, instead of negative 12, we'll write negative 3 times 4. Times, and just keep writing the times, and then put 3 times 5. Like this. All over 5 times 4. Just like this. Okay? Now cancel the 4's and cancel the 5's. So now n equals negative 3 times 3. Well, negative 3 times 3 is negative 9. So n equals negative 9. That's how I do that. Now, if you did it by doing it the really, really hard way, I'm sorry. Okay? Moving on to number 18. we have negative 11 over 8. A equals 11 over 8. Just flip it. So we're going to multiply both sides by negative 8 over, remember that negative sign always stays with the top number. Multiply both sides by negative 8 over 11. The 8s and the 11s cancel over here, leaving me with A equals. Well, now check this out. The 11s cancel, and so I have negative 8 over 8, which is just negative 1. A is negative 1 on number 18. Number 19. Negative 4 over 7p equals 1 over 7. Well, remember, just flip it. Okay? So we're going to multiply both sides by the flip. So negative 7 over 4. Negative 7 over 4. Cancel, 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 cancel. P equals. Okay? Well, now I have these canceling out, leaving behind a 1. So I have negative 1 on top over 4. So P equals negative 1 over 4. And our final problem, ladies and gentlemen, you've made it to number 20. 2x equals negative 2 over 3. Well, remember, it's 2 over 1x. So if you do that 2 over 1, you won't make the mistake. Just flip it. 1 over 2. Over here, 1 over 2. Everything cancels. X equals negative 2 times 1 is negative 2. And 3 times 2 is 6. And we just reduce that fraction by dividing top and bottom by 2. Leaving x equal to negative 1 over 3. So the final answer to this 20-question test is negative 1/3. Thank you all so very much for watching. Please make sure to like, subscribe, comment, and hit that notification bell.